First thing we have to learn here is that in this course we are going to be using graphs, and in particular most of my graphs are going to be two-dimensional graphs in which what we are going to study is the relationship between two variables. Those two variables are going to be quantity and price. Okay? So we're going to draw here things that relate, price and quantity. And in particular, we are going to study what we call demand and supply functions. A demand function is basically going to tell us, at each particular price, how many units people are going to buy, how many units people are going to demand. Okay, so apparently the price of this class was too low because the price was low, so a lot of quantity, a lot of people wanted to come. If I was charging you $2,000 to attend this class, perhaps less people would be here. So what we are seeing is that if we are asking ourselves, how much demand there's going to be for my product, there has to be a relationship between price and quantity. And that relationship that we call a function, what we are going to say is that the price is a function of the quantity, or the quantity is a function of the price. What it means is that there exists a relationship. If the price is very high, very few units will be sold. If the price is very low, more units will be sold. That means that relationship, in terms of a demand function, is going to be a decreasing function. Right? Everybody understands that? Yeah. The lower the price, the more units I will be able to sell. How do we find what this function is and all these things? We will talk about next week. But of course, no matter which product you are selling, this is something very important for you to know and very difficult for you to know. Because in order to see how many, at this price, how many units you would be selling, you need data. And it's data that it's very difficult to obtain. Why? Because, of course, consumers don't want to tell you how much they're willing to pay for something, right? If I wanted to get a lot of money from you and I said, how much are you willing to pay for this lecture? What would you tell me? Would you tell me the real price? Or would you try to say a lower price? Lower price, right? So the whole story is we don't know where this function comes from. We don't know how do we get data, but we know that there's going to be a relationship between price and quantity. And we also know that that relationship is going to be a decreasing one. So if we want to express that in a mathematical function, what we would say, for example, is that Q is a function of the price, meaning there is some mathematical expression that relates the Q with the P, right? And it relates them because this is a decreasing function in a negative way. What does this mean? It means that the higher the price, the lower the quantity, which is exactly what we are seeing in this graph. Everybody sees that? Yeah. So there has to be a negative sign here. Okay? It doesn't need to be a minus P and that's it. There can be some number here multiplying the P. It could be minus 2P, or it could be minus 6P, or it could be whatever number we want. But the relationship between the Q and the P, it has to be negative, right? And it can be, some number minus something. So example, it could be 50 minus, 5P. This could be a demand function, okay? It tells us that the higher the price, the lower the quantity. Now, one thing we will be doing a lot in this course is we are going to be representing these functions in graphs. So instead of doing something abstract like I did here, we may try to be a little bit more precise. For example, let's try to see whether this function actually cuts the axis. So for example, if the price is 0, how many units would I be selling? Let's see the function. 50, right? If price is 0, so it's here where we are cutting the horizontal axis. If price is 0, 5 times 0 is 0. So Q equals 50. So I already know one thing that is important, which is that point is 50. Okay? And I can do the same with this point. If Q is 0, so if we are here, what is the maximum? If I want to sell the very, very first unit of this product, what is the maximum price that I can charge? What is the maximum? What is this price? Well, if P is 0, if Q is 0, I have that 0 equals 50 minus 5P. And now we have to do magic in the night, okay? One thing that most of you learned in high school is when something is with a negative sign on one side, how does it go to the other side? Positive sign. So 5p equals 50. And now let's go for the next one, which is, okay, if I have a number that it's multiplying a variable, how do I get rid of that number? It's multiplying, it goes dividing. So p equals 50 divided by 5, p equals 10. Okay? As simple as that. I know I'm starting very basic. It's going to get a little bit more complicated. Okay? But I see some faces, some people are already panicking. So this is interesting. Okay? Everybody sees this? This is it, right? So this is the type of things that we are going to be studying. In Carolina's part, instead of looking at price and quantity, her axes are going to be, for example, she's going to be looking at what she calls, she's going to be calling production function, which is how many units of my product I'm producing, depending on how many production factors I'm using. So, for example, in order to produce something, I'm using capital, let's call it K, right? I can say, okay, the more capital that I use, right? The more product, let's call output Y, let's call it Y, I don't know why, but we call it Y, okay? Then we're gonna have a relationship between how much input I'm using and how much output I'm producing. And this function, we expect it to be increasing, decreasing, increasing, right? The more we use of a production factor, the more we will produce. So perhaps this will look like this, okay? So, but this is, this is what we are going to be using all the time, functions, meaning some variable is related to some other variable. The more we have of one, the more or less we will have of the other, right? Here we are representing how much we are producing. The more capital I use, the more I produce. Here we are representing demand, and we will be using other functions, right? Now, one thing that is important is, okay, these functions are going to be there. We are not going to make them very, very complex, right? These functions could be, a function could be something like this, and this, and this. Could be very complex, right? It could have a mathematical formula that could be much more complex than that. But because this is not a math course, and what we are interested is in you really understanding the concepts, our functions in general are going to be either linear, this is linear, or the most difficult thing we will be seeing are quadratic ones. And now I'm going to ask the Sesame Street math question. Seriously, this was asked in Sesame Street when I was 5 years old, and I saw it, which was the following. And the answer is not so easy. By the way, I'm going to be making jokes today and in the following classes. Very bad jokes because I'm not a comedian, okay? And some of them, I will be making a fool of myself too. So, just to keep things entertaining, and otherwise, this can be, we'll commit suicide, right? So I will try to be funny as much as I can. If anybody feels offended by my jokes, let me know, okay? Or throw me things or whatever. But what I mean is, I'm not going to be treating anybody like an idiot. But for example, the next question I'm telling you is Sesame Street math, but many of you will not know the answer. Please raise your hand if you can explain me what is the difference between a line and a curve. And please don't start doing that. I want to see an argument here. What is the difference between, think about it, before we see the answers, think about it. What is the difference between a line, a straight line, and a curve? You raise your hand. What's your answer?
The line is the quickest way to go from one point to another.
Okay, but we are not going to go anywhere. We're staying here. It's true that is the minimum distance between 2 points. That's true. But as a characteristic, a graphical characteristic, what would you say? Yes. Next.
So the line is just an x, and if you have like a number like in the top, the name, how do you call it? Like an exponent, then it's like a curve.
Did you see Kermit in Sesame Street saying exponent and all these things? No, let's talk Sesame Street then. Is your name Andrew? Oh, those names are very useless. Okay, whatever.
The line has a straight slope and the other one has a different slope.
Now we're talking about something. The difference between a line and a curve is the slope, right? Now, what do we mean with the slope? Now, when I say the word slope, many of you start doing like this, the inclination, right? What is the slope?
Change of
The rate of change.
the rate of change, right? So for example, when in the summer we have the Tour de France and we have the Spanish Vuelta in cycling, right? I always draw a guy cycling. This is, you know, I'm not a comedian, I'm also not a drawer, right? So if we have a mountain and you're watching a cycling competition and they say, oh, this guy has to go through this big mountain and the slope is huge. What it means is when they say, what do they mean when they say that the slope is 10%? What are they saying? The gradient inclination, but really, let's talk Sesame Street. What are they saying? That for every
Step.
100 meters they go, how much do they go up?
1 meter.
Right?
Yeah.
10%.
10 meters.
So if it's 100 meters, it's 10, right? So when we're saying the slope is 10%, what we say is when you were saying the gradient is a change, right? For every change in horizontal that we go, how much do we change in vertical? That's the slope. Yes.
Maybe don't work the curtain, because it's,
Sure. Any lighting
there is a
condition?
button there next to the.
Where?
I'm not next to it.
Guys,
Slope now.
oh, I have my minions here.
It's gonna take some time.
It's gonna take some time, but just follow what I'm saying. So when we say the slope, what we are saying is how much do we go up as we go horizontal, right?
Or down.
Yeah, of course. But in this course, the only way is up, okay? Okay, so no, it's not. Actually, this is down, right? So how much do we change vertically when we change horizontally? Now, the difference between a line and a curve is in a line, in a straight line, what is the difference between this? This is supposed to be a straight line, by the way. What is the difference between this and this? The difference is this is a straight line, the slope is constant. Everybody sees it? Well, here the slope changes. That's the difference. So in many of the graphs we are going to be using, the functions we will be looking at are straight lines, so the slope is constant. Sometimes we will have curvatures, which are more interesting. Why? Because if this is a curve, right? This is a curve. One thing that is going to be interesting is that we are going to be able to calculate a point that is the maximum, right? So when we have curves like this, we will try to find maximum here. For example, we will represent functions like this. We will represent the profit function, how much money you're making with your product, depending on what is your price and how many units you're selling. And obviously, because this course is about making good business decisions, obviously, if this is a profit function, we will want to have the maximum profits. So we will want to calculate the maximum of the profit function. Everybody's with me? Now, for, you know, Sesame Street Plus, how do we calculate the maximum? What happens geometrically, what is going on in this point, which is the maximum of this function, that is not going on at this point, or at this point, or at this point. What's going on here?
You have to calculate
Don't tell me what calculation to do, we are not there yet.
You have to find out where the slope is equal 0 of the derivation.
Exactly. At the maximum, or, by the way, at the minimum of a function, the slope is 0. Everybody sees it? When you reach the top of a mountain, if you move a little bit to the left or a little bit to the right, you may fall, but you are not going to change vertically if you're really, really at the top. I mean, if you really move just very, very, very tiny bit to one side, you are at the same height, right? Well, at this point, of course, if I change a little bit to the right, I go up by a lot. Or here, if I move a little bit to the left, I go down by even more. I also go down. Okay? Everybody sees it? So we are going to be calculating maximum and minimum at when the slope is 0. Yes? Okay? Of course, with a linear function, we cannot calculate the maximum or the minimum. Everybody sees it? Because if the slope is constant, and in this case the slope is positive or negative? Here the slope is positive. If we move horizontally to the right, we go up. So here the slope is positive. Here the slope is negative, right? So neither here we can calculate a maximum or a minimum, because if the slope is always the same and it's not 0, it's never going to be 0, right? So I could go up and up and up and up and up, and I could, the more I go to the right, the more I would go up. Or here, the more I go to the right, the lower I would go down. It would be impossible to calculate a slope that is 0, right? There's no maximum or minima when the function is linear. When the function is a curve, we can calculate what is the maximum or the minimum by equating the slope equal to 0. Yes? Okay, that was the concept kind of way of talking about this. Now let's talk mathematics. How do we calculate a slope? What is the mathematical concept to calculate a slope? You saw this in high school. Many of you did. What is it? The derivative. The derivative, okay? We are going to be calculating derivatives. Do not panic. We are going to be calculating 3 derivatives. Okay? Very simple. You just have to remember 3 of them. Yes?
3 to get the slope of
We're going to calculate the slope
x
of our horizontal line.
x0 divided by epsilon y.
Good try. No, come on. No. That's one of the ones we are going to calculate in just a second. Okay? So we have to be able to calculate the slope of a function. Okay? But first, let's start representing a function. Okay? So, for example, imagine I tell you, I'm not going to talk Q and P, I'm going to talk Y and X. This is X, this is Y. Imagine I tell you that my function is Y equals, you won't, this is something you saw somewhere. Okay, that's fine.
No.
Which one do you want? X plus B. Anybody wants to do this? Can I do something a little bit more fun? Come on. Okay, thank you. Let me do what I was thinking about. Okay? So, x squared. Let's assume the following. I'm gonna give numbers to make things easier. X squared, minus x plus 3. This is my function. Okay? First thing I want to do, I want to represent this function. What is the easiest way to draw a function? What is the easiest way? Give it values. Which values? The easiest possible one, right? So if x is 0, how much is y? 0 squared is 0, minus 0, 0 minus 0 is 0, plus 3. So I have 1 point. I have 1 point. Yes, we made it. Okay. I like MBAs, you're so enthusiastic. I love it. Okay. So if x is 0, y is 3. Okay? So far so good. Now let's give it another interesting number. The next one. 1. Okay, that's wow, it's gonna take a long time to grow this. So if x equals 1, how much is y? 3. Let's do it. Y equals 1 squared, which is 1, minus 1 plus 3. Did I do this right?
Yeah.
Yes. Good. Okay, this is weird. So x0, x1, we have 1 point here, we have 1 point here. If we have 2 points, we may already be thinking, okay, this is a very easy function to draw, right? Because I put this point with this point, and then this will be the same all the time. Is it that the case? No. It's not, right? If, for example, x equals 2, y equals 2 squared, which is, okay, that one we know, that's good. Minus 2 plus 3, right? So this is 4. 5. I could fake it and say, oh, I did it on purpose. Anyway. So 5, so that would be something like this. So far we know this is something like this, right? And we could continue. Now, I don't want to continue. I mean, I do want, come on, let's do this. X equals 3. Y equals 9 minus 3 plus 3. This is 9, okay? I'm not gonna do more than that. So it seems like this is starting to be like this. Okay? So this is 5, and this is 9. Okay? Everybody's with me? Yeah? Now, we see that at the beginning, this has 0 slope. From here to here, we move 1 unit to the right, and we don't go up, right? and then the moment we move from 1 to 2, we start going up, and then the moment we move from 2 to 3, we start to go up even faster, right? Is it always going to be the same? I don't know. I could still be doing points like this all the afternoon, but it would be a little bit boring. So what I can do is calculate the derivative, see what is the slope of this function, and then see whether at some point the slope is 0. So I know the maximum or the minimum, where it is. Everybody's with me? Yep. Good. So let's calculate the slope. We're going to do 3 very simple derivatives here. Don't worry, this is not my class. What is this, accounting or what is this? Well, come on, if you know finance, you have to know what we are doing. Okay, or not. Anyways, so we're going to do the derivative of 3 very simple functions. The first one is the derivative of a constant, where k is a constant. Again, another Sesame Street economics, which is mathematics. What is the derivative of a constant? So how much does a constant change? Nothing. A constant is a constant, so it doesn't change. So the derivative of a constant has to be 0, right? So what we're saying is y prime, and y prime is what we call the derivative. In order to talk about a derivative, we're going to talk about that variable or that function with a prime, or the same way of saying the same thing, derivative of y with respect to x. Well, if y is a constant, the derivative is 0, right? So for example, if y equals 6, what is y prime? What is the derivative? 0. Come on, I know it too. Come on, let's maintain the enthusiasm, right? So let's draw it. If y equals 6, what we're saying is that y is always equal to 6, no matter how much x is. Y, just a second please. Y is always 6, so we are saying if x equals 0, y is 6. If x equals 1, y is 6. If x equals 2, y is 6. So we are saying this function is always like this, and therefore the slope is 0. Everybody's with me? You had a question?
Yeah, I took derivatives the last time in high school, so just one, like...
Sure, that's what they're here for.
What is it again?
Okay.
I never studied derivatives.
How well did you do in high school?
Just why are we using derivatives to determine the slope?
We are saying that the derivative,
At its core, what is
that
it?
the derivative is the calculation of a slope. The derivative is telling me, when I write a d here, what I'm saying is, exactly what I'm saying is, with this d, I represent, come on guy, I'm trying to talk to him, so if you distract him, I cannot.
No, it wasn't distracting.
You were, because I was talking to him, okay? So what we are saying, what we are meaning with this d is change in d. The d means change, right? So what we're saying is how much the y changes when I change the d. What is the change in y when I change dx? And what we're saying is if this is if the derivative is 0, if the function is actually a constant, if the function is always equal to the same number, it doesn't change. So the derivative is 0. It means the line or the function we're trying to represent is completely flat, because the slope is 0. Something that is completely flat has a slope of 0. Everybody's with me?
Yes.
By the way, if this is x and this is y, and this is a completely vertical line, what is the derivative? Or what is the slope of a completely vertical line? Infinity. What do we say? Well, what we say is, why do we say this slope is infinity? Why do we say this derivative is infinity? Because what we're saying is, if I start at this point and I move just a little bit to the right or to the left, I go to space, all the way up. So the derivative here is infinity, the derivative here is 0. Everybody's with me? Somebody, I heard some no's, so I want to. No, come on, that's good. No. What's
I don't understand what is infinity in one case and 0.
Okay, because the derivative is how much the y changes when I change the x, right? Here, if I change the x, how much the y changes? It remains the same, so it doesn't change. So how much does it change?
No.
Nothing. And how do we say nothing in mathematics?
No, that I understand.
That's good. Now here. Now what we're saying is, if I change the x, how much the y changes?
But
So-
You're changing it.
You can't change it.
Imagine I could, in the limit. You know, mathematics is a little bit like philosophy, right? We are thinking about absolute. No, seriously, it is. Many philosophers were mathematicians in Greek times, right? So the idea is we're talking about a concept. What we're saying is, of course, you're not going to change it, but if you were changing just a tiny atom bit, how much would you go up? All the way, because you know this doesn't stop. So it changes infinity. It changes as much as it could. How do we say in math as much as it could? We say infinity. Make sense? Good. Great. Thank you. Okay. So the first thing we learned, the derivative of a constant is 0. Fine. Now, the derivative of a constant times a number. So you like, for some reason, you like letter m. So I'm going to write m. M is going to be some number, and x is going to be my variable. So still my axes are x and y, and m is a number that multiplies the x. So for example, in my example, m is going to be equal to, so what I'm saying is y equals to x. Okay? Everybody's with me? Now, the derivative. So what is the derivative of a number multiplied by my variable? How much y changing y when I change x? We are going to see it. Let's give numbers. So if if x equals 1, how much is y in this function? 2. If x equals 2, how much is y? 2 times 2, which is 4. If x equals 3, and I will stop there, y equals 2 times 3, which is 6. So in how much are we changing the x? In 1 unit. How much is the y changing? In 2 units. The change is 2. The change is 2. Right? For every 1 unit we move to the right, we go up 2 units. That's what we're saying. Now, if x was equal to 4, how much would the y be? 2 times 4, which is 8. So how much would the y change again? 2. Everybody sees that the derivative is always the same. It's always 2, right? It's always 2. 2 is m. So the derivative of a number times a variable is the number. Everybody's with me? And now, because that number is always the same, it means that the derivative is constant, right? So if the derivative is constant, what is the definition of a straight line? A straight line is a function whose slope is constant. So this is a straight line. Everybody sees it? Because the slope is constant, it's always the same, we can draw this as saying, okay, if x is 0, y is 0. If x is 1, y is 2. If x is 2, y is 4. So this would be a straight line. Everybody sees it? Right? Now, this is a straight line because it has a constant slope equal to m, which in our case, in our example, is 2. Everybody sees it? And it's a straight line because the slope is constant. Now, can I calculate the maximum or the minimum of this function? No, because if the slope is always equal to 2, it's never going to be equal to 0. As simple as that. Everybody sees it? Okay, now let's go for the final one. The final one. Let's calculate one, let's do one function where we can actually calculate the maximum of the minimum. Okay? So, as I said, feel free to, no problem in leaving it. I see everything, okay? Okay, so what if our function is actually a variable x to an exponent, and that exponent is a number, right? This is a little bit more complex. Okay, what happens? Well, let's do an example again. Let's start with the simpler one, y equals x squared. And let's give values. If x equals 1, how much is y? 1 squared, which is 1, right? If x equals 2, y is x squared, which is 2 squared, which is 4. If x equals 3, y equals 9. 3 squared is 9. So the first thing you see here is that the change, I'm always changing the x in 1 unit, but the y is changing here, it's changing in 3 units. Everybody sees it? But here, it's changing in 5 units. And if I go even further, and x equals 4, y is going to be equal to 16. So now it changes in 7 units, right? What it means is that the slope, the derivative, is not constant, it's changing. Everybody sees it? So this is not going to be a straight line. Yes? Meaning, if x equals 0, 0 to any number is going to be 0. So it starts here. But if x equals 1, y is going to be equal to 2. But if x equals 2, y is going to be equal to 4. But if x equals 3, this is going to be 9. So I'm already seeing that this is something like this. It's not a straight line. Everybody sees it? Yes? So what is the derivative? What is y prime? What is the change in y when I change x? It's going to be, this is a formula some of you may remember from high school. It's m times x, m minus 1. This is the most difficult formula you're going to learn in this course, I promise. It's going to be easy, right? This is it. So let's do the derivative here. If y equals x squared, what is the derivative? What is y prime?
2x.
2 times x to exponent 1, which is x. X to exponent 1 is x. Everybody's with me? So this is the slope.
Okay.
Yes? Now, if we wanted to calculate the maximum, if you're seeing already the shape of this function, which looks something like this, can we actually find the maximum of that function? Meaning, can we ever equate the slope of the function to 0? Can we or can't we? Yes, we can. Yeah, I like the attitude. So can we make 2x, no, what is the slope? The slope is 2x. Can we make y prime equal to 0? So meaning the slope 2x equals to 0? We can. When this 2 goes to the other side dividing. So we have x equals 0 divided by 2, which is 0. So what we are saying? What we're saying is the only point in this function where the slope is 0 is where? Here. Actually, this function, if we could give negative numbers, which we will not in most of the economic interpretations, this is going to be like this. This is the only point where the slope is 0. Meaning, what we have calculated here is not a maximum. It's what? It's a minimum. Right? So be careful when you calculate the slope, when you calculate the derivative and make it equal to 0, be careful to say, hey, I calculate the maximum profits I'm getting because I make the slope of the profit function equal to 0. Be careful. You could be finding not the maximum profits, but the minimum profits, which, you know, will make a study look very, very bad, right? We taught these people to calculate the minimum profits. Well, that's not what you're here for, okay? So you have to make sure when you calculate the slope, the derivative, and make it equal to 0, you have to make sure it is a maximum what you find and not a minimum, okay? Now, how do you know if what you found, without doing the graph, how do you know if what you found is a maximum or a minimum? Let's go into deeper space. We calculated the first derivative. Let's go for the second derivative. That's the maximum we're going to go. Okay, don't worry too much. So what is the second derivative? The second derivative is as easy as once you have taken the first derivative, you take it again. Right? So if my function was y equals x squared, the first derivative we say was 2x. Now, let's calculate the second derivative. What is the derivative of 2x?
2.
Given that my function now is a number multiplied by a variable, what is the derivative of a number multiplied by a variable? The number. Everybody with me? Yes? Very good. Now, so I find that the second derivative is number 2. That I don't care about. What I care about in order to know whether what I found with this point was a maximum or a minimum, what I care about is about the sign of this number. If the number is positive, it means we have found a minimum. minimum. Okay, when the number is positive, when this is bigger than 0, when the second derivative is bigger than 0, it means we have found a minimum. When the second derivative is smaller than 0, we have found a maximum. Right? So in my example, given that the second derivative is positive, what I found was a minimum. Everybody's with me? Yes? Should I repeat? So the slope is the derivative. That's the first thing. We have found 3 ways or 3 derivatives. We are not going to do more difficult than that. We have found 3 derivatives that we care about. One is the derivative of a constant, which is 0. 2 is the derivative of a constant multiplied by a variable, which is the constant. 3 is the derivative of a variable to some exponent, which is a constant, which is going to be the constant times the variable to the exponent minus 1, m minus 1. Okay, that's what we found. Now, if we calculate the first derivative, we will calculate the slope. If the slope equals 0, we will be at a maximum or at a minimum. In order to know whether it is a maximum or a minimum, I calculate the second derivative. If the second derivative is positive, sorry for that, I'm at the minimum. If the second derivative is negative, I am at the maximum. That's what we have learned. Okay? We're almost there. Actually, we're doing very good. In terms of timing, hopefully in terms of understanding too. But in terms of timing, we're doing good. I think in half an hour we will be out of here. Okay? And I'll sleep on the sofa. So I'm joking. That was not very funny, but it was a joke. Okay? So let's all together, let's calculate a derivative that is a little bit more complicated using all the concepts we have seen. So for example, imagine my function is the following. Y equals 3x cubed minus 2x minus 5x squared plus 10. I could do 2 things in order to know what shape does this function have. One is I could be giving values to x and calculate how much is y, and I would be joining the points. Or a very good way to see this is, okay, let's start calculating derivatives. Right? So let's do it. What is the derivative of this function? What is the change in y when I change the x? So first now we are putting things together. We have something here in which we have a constant times a variable to some exponent minus another constant times the variable squared plus a constant. Okay? Now, one thing that I didn't tell you, but I need to tell you, is that the derivative of some of things when we are adding or subtracting things is the sum of the derivatives. So nothing very complex. I have to calculate the derivative of this minus the derivative of this plus the derivative of this. Let's start with the simplest one. What is going to be the derivative of number 10? Number 10 doesn't change, so here is plus 0. Very easy. Now, let's start with this one, which is a square. Now, we have the derivative of a constant times a variable squared. So, it's the derivative of a constant times something that varies. What is the derivative of a constant multiplied by something that changes? The constant, right? So it's going to be 5. And then I have the derivative of x squared. What is going to be the derivative of a variable to some exponent? It's going to be the exponent, so times 2 times x times 2 minus 1. So 5 times 2x. Yes, we will know that that's 10 in a second, but not yet. Okay? There was a minus sign here, so I keep the minus sign there. And now let's go to this one. Who can help me with this one? So we have first the number, so it's 3, times the exponent, so it's 3, times x to the exponent minus 1, which is 3 minus 1, 2. Right? So this is 9x squared minus 10x plus 0, plus nothing. That's the derivative. Right? Everybody's with me? Now that I know, so now I'm asking you, is this function a curve or a linear, or a line, or a straight line? Curve. It's a curve. Why? Because its slope changes with the x. If x changes, the slope changes. Everybody's with me? Have I found the maximum or the minima? No. How do I find the maximum or the minima? Equating the slope to 0, right? So let's do it. When the slope equals to 0, when the derivative equals 0. So when 9x squared minus 10x equals 0. Everybody's with me? So that means 9x squared, and because I have minus 10x, what can I do? Take it to the other side. Plus 10x. Right? And now I want to get rid of the x squared and the x. What can I do? The x is multiplying here. I can take it to the other side, divide it. So 9x squared divided by x equals 10x divided by x. No, what am I doing, Pedro? I'm just doing stupid things. Yes? Everybody's with me?
Yep.
Now, what is x squared divided by x?
X.
X. So 9x equals 10. So x equals what? 10 divided by 9. Okay? So what I know is that when x equals 10 divided by 9, I have an interesting point. When x equals 10 divided by 9, the slope of this function is going to be 0. That's what I have learned. When x equals 10 divided by 9. Do I know whether this is a maximum or a minimum? I don't know yet. I don't know yet. Why don't I don't know it? Because I haven't calculated the second derivative, which is what tells me whether this is a maximum or a minimum. You see, everything falls into place? Yes, you had a question.
You're assuming if x is not 0, if x is 0, you cannot divide it.
Of course. We wait and see. We will do that in a second. Let's first look at whether this point is a maximum or a minimum. Okay? So, now, I have that when, where did I find this? When the derivative, if that is the derivative, I know that I have a maximum or a minimum at the point where x equals 10 divided by 9. Everybody's with me? Yes. Now, how do I know whether that's a maximum or a minimum? I have to calculate the second derivative. What is the second derivative? So if my first derivative is 9x squared minus 10x, what is the second derivative? The change in y prime divided by x. Meaning, what is the derivative of 9x squared? 18x. Minus, what is the derivative of 10x? 10. So the second derivative equals 18x minus 10. Now, do I know whether when x equals 10 divided by 9, this is a maximum or a minimum? Not yet. I don't know it. Why? Because actually, when x equals 10 divided by 9, I'm gonna have, I may have a maximum or a minimum. Why? Because this number could be positive or it could be negative. Everybody's with me? Depending on what is the value of x, this could be positive or negative. But do I know, at the point that I'm trying to study, do I know what the value of x is?
Yes.
I do. It's 10 divided by 9. Everybody with me?
Just have a quick question. We can find out the maximum or the minimum at the first derivative.
Yes?
We don't need to go through the second.
No, this is not the maximum or the minimum. This is the slope. This is the slope. The first derivative is the slope. The maximum or the minima, we calculate it by taking the slope and making it equal to 0. And then we find the point. But this is the slope in general, at any point. Depending on what is the value of x, the slope will be different. Everybody's with me? That's a very important question. Yes? But now, in order to know whether this is positive or negative, given that I'm trying to study this point, 10 divided by 9, right? I can substitute the 10 divided by 9 there to see whether this is positive or it's negative. Everybody with me? So 18 multiplied by 10 divided by 9 minus 10. Everybody's with me? Is this positive or is this negative? Now is when I allow you, if you want, to use your calculator. It's positive, right? Why? Because the numerator is bigger than the denominator. So this multiplied by 18, this is going to be bigger than 10, so minus 10, this is going to be positive. So that means, at this point, we have found what? A minimum. That's it. Everybody with me? We know that at that point there's a minimum. Actually, we can substitute the 10 divided by 9 all the way here and see what is y when x equals 10 divided by 9 and know whether that minimum is here or here or here or here or here, wherever it is. Everybody's with me? I could do other things, which is ask myself, is there actually a maximum in this function? And the question is, well, yes, you could calculate when there is a maximum in this function. Well, there is a maximum whenever this turns negative. So when does this turn negative? Well, when x is smaller than 10 divided by 18. When is 18x minus 10 negative? When 18x is smaller than 10, meaning when x is smaller than 10 divided by 18. Everybody's with me? So there are two interesting points here. One is 10 divided by 9, and the other is 10 divided by 18. It's maybe something like here. So that's maybe telling me something like this function may be like this, and then it may be like that. There's a minimum here and a maximum there. I'm not being very precise, but I'm giving you the idea. Everybody understands this? This is basically the most important things. We are going to look at two more things, and that's going to be it. Okay? Questions on this? So you're asking yourselves. Why don't you ask me? I promise I have studied this a couple of times.
How do you calculate the maximum? That just gives you an area where x might be maximum, but that's not an equation. It's not x equal to something. So when do you know at what point it will be maximum?
Sorry, if we don't listen, we are not going to learn anything. Sorry about that.
So at what point do we know there will be a maximum?
We know there will be a maximum when the slope equals to 0. So we will know there will be some interesting point here.
How do you calculate?
So what you're asking is, Pedro, you know, we are not, what you're saying is, Pedro, you're not finding 2 points, you're only finding 1 point, and you have found that that point is a minimum. So is there a maximum here? That's what you're asking. And the answer is, no, there is not. Okay? So all this calculation I was doing here, I was trying to trick you into trying to think, how would you think there is a maximum? Well, you would have to make the second derivative negative, and therefore you would have to do that. But that's actually not true. You cannot make it, you know, this is always going to be like this in this case. But I was trying to show you more things, you know, that I could do with this function. Okay, so it was not a very good example, but I think you get the idea, which is the important thing. Yes?
Was it a shortcut to quadratic functions? The x method? Was it a shortcut?
So, you know, the shortcut is if you have y equals x squared, the derivative is y equals to x. That's it. No, so ask me again, if I didn't answer your question.
No, I was thinking about the 9x squared versus an x. There was this method which you remember the PQ. Yeah, I don't know how to explain.
Can we help?
The solution of x1, x2, I think is saying.
Yeah.
And you can say minus b plus minus
Okay.
square.
Yeah, x1.
So what you're saying is, what happens? No. He's thinking when you have an expression, now is when I'm going to have the m and the b that you wanted to have. When I have y equals a times x squared plus b times x plus c, please silence so everybody knows. The solution of a polynomial, right, is x equals minus b plus minus the square root of b squared minus 4ab divided by 2a. Okay? I remember this.
Yeah.
Okay? Many of you remember this. Don't worry. We are not going to be using this. We don't need it. Okay? This formula is true, and you can actually use it. But this is just a way to find, you know, what happens when all these things equals 0. This is the way you solve it. But the problem is, we are not going to make y equal to 0. Right? What we are going to make equal to 0 is y prime. So we care about these things. You don't need to remember that formula. don't worry. Okay? More questions?
But in this equation, don't you get two answers? Because if you take one x outside as a common factor, you would have x equals 0, it's 0, and x equals...
Very good point. So you're saying, Pedro, you solve it like this, and it's true that you have x squared divided by x, so you simplify, you just get 1x. But actually, you could have solved it by taking the common factor x and say x equals 9x minus 10 equals 0. And this polynomial actually has two solutions. When I have the two things that are multiplying, this thing multiplied by this thing equal to 0, actually could be two things. One is actually what we're doing here, which is either 9x minus 10 equals 0, so x equals 10 divided by 9, very good. Or it could be that what it's equals to 0 is this, so x equals 0, right? So I have two solutions. Now, if x equals 0, right? If x equals 0, the first derivative is going to be 9 times 0 squared, which is 0, minus 0. So y is going to be 0. So all this is saying is that at point where x equals 0, the function doesn't continue anymore. I cannot calculate anything else, right? But what I'm saying is I was giving you this in order to make it simple. Sometimes we will see functions in which there will be two solutions, and therefore we will have what I was trying to draw you there, which is a minimum and a maximum. But in this case, we cannot do it. Okay? X equals 0. Everybody with me? More or less? So, just as a summary, remember, the difference between a line and a curvature is that the line has a constant slope. The slope is the derivative. The derivative, we calculate it by knowing that the derivative of a constant is 0, the derivative of a constant times a number is the constant, and the derivative of something to a variable to an exponent is the exponent times the variable to the exponent minus 1, right? And we can construct these things. Now, we find the maximum or the minimum by calculating the first derivative and making it equal to 0, and we know whether it's a maximum or a minimum by making the second derivative equal to 0. That's what we have learned so far. Okay? Two more things I want to talk about before we finish. One is areas. You know, sometimes we're going to be interested about calculating areas. Don't worry. Many of you may remember that we calculate an area by doing an integral. Okay? No worry, no panic, no integrals in this course. Okay? Why? Because most of the functions we will be using are going to be lines. Meaning the area below a line is going to have a very simple form. It's going to be a triangle, it's going to be a rectangle, things like that. And for that, we know formulas. Okay, so we are going to remember what is the formula of the area of a rectangle, of a triangle, etc. Right? So just to remind you a few of these shapes. Why do we want to calculate areas? So this is going to be very interesting. Now I'm going to talk economics for a second. Now we're going to talk business, no math, for a second. Remember that I started the lecture talking about demand function, right? I was talking about quantity and price, right? And I was saying, look, this will be my demand function, telling me if the price is high, you sell this number of units. If the price goes lower, you sell more units, right? So why am I interested in calculating areas? Well, because, you know, if this is my price, right? If this is my price, at this price, let's call it P star, at this price, I'm going to be selling this number of units. Everybody's with me? So this area is what? Now I'm talking about economics. I'm not saying that's a rectangle. Of course it's a rectangle. But in terms of economics, what is that? Price times quantity. Revenue. It's revenue. If I'm selling this number of units at this price, how much money I'm getting? Well, for the first unit, you're getting this much. For the second unit, this much. For the third, this much. For the fourth, for the fifth. For all the units you're selling, you're getting the same price. So this area is your revenue. Everybody sees it? So revenue is going to be price times quantity. a good business decision, which is what we are trying to learn in this course, is how do I maximize my revenue, how I make the most money. So I will be trying to maximize price times quantity, right? Why do I say that revenue is actually a rectangle? Because what is the area of a rectangle? Remember from high school? Length times height. So this area is length. What is length? Quantity. What is height? Price. So this is revenue, the area of that rectangle. Make sense? Yes? That's it. So we have to remember that the area of a rectangle is length times height. Now, in this course, I'm also going to be interested about the area of this triangle. Why am I interested about the area of that triangle? Well, because I'm a freak, but also, you know, also, yes.
Price sensibility.
Sorry?
The price sensibility.
The price sensibility is going to have something to do with the slope of the function, because the price sensibility is going to say, if I lower the price a little bit, how much the quantity changes, or if I change the quantity a little bit, how much higher price I can change. So that's going to be the slope. The price sensibility is going to be the slope. But the triangle is interesting because if I'm selling at this price, sorry if you're seeing my path all the time. If I'm selling at this price, what is that triangle telling me? So for the very first consumer, the person who really likes your product, the person who is willing to pay a lot of money for your product, right? He's going to be very happy that the price is not this high, but it's this high. Everybody sees that? He or she is willing to pay all this much, but they only have to pay this much. So the difference between how much a consumer is willing to pay and how much they actually have to pay, we are going to call it, it's going to be a measure of welfare, of how happy the consumer is. In particular, we are going to call it consumer surplus, right?
Is it opportunity cost as well?
Sorry?
Is it opportunity cost?
Wait and see. We let's not get too much. Today is math, next week economics. So let's not go too much into that. The opportunity cost is going to be related, but this is the concept we're trying to see here is imagine for some weird reason some of you like my tie. I know you don't, but imagine you like my tie. Come on, it's not that bad, right? And imagine let me ask you, how much are you willing to pay for my tie? This is a business. You don't like that. Only 10 euros?
You are negotiating, it's a negotiation.
No, we are not negotiating. Remember, professor, student. I also teach a negotiation class. Another day. Anyways, so imagine you're willing to pay 10 euros. Imagine that's true. 10 euros, you said? You have them? Is that true? Okay, imagine is anybody willing to pay 10 euros? It costs quite more than 10 euros. Like 13 or something. No. Actually, this is the tie I got married with, so you know. So I'm not. It's so easy to fool you. It's not. Anyways, it's an important tie for me. It's not the tie I got married to the first time, but no, it's not. No. Anyways, it's an important tie for me. Let's leave it. Okay. So imagine somebody's willing to pay 10 euros for this tie, and I say, oh, it only costs you 8, or it only costs you 2. Let's imagine you're willing to pay 10, and I say it only costs 2, right? So a way to measure how happy you are is by asking you, I could ask you how happy you are, and you say, oh, I'm very happy by buying your tie because I was willing to pay a lot of money and I didn't pay that much, right? Well, what we are going to do in this course is, because measuring happiness, consumer happiness, is complicated, right? It's not tangible, right? Somebody bought something today, I guess so, right? You had lunch at least, right? So how happy are you with whatever you bought today? Right? I could ask you how happy you are, and you would say, oh, I'm very happy. But I want a number. I want you to express that. So the way economists think, we are weird. The way we think about this thing is, okay, we measure happiness in euros, and we measure happiness by how many euros you save with respect to what you were willing to pay, right? So the difference between how much you're willing to pay and what you actually pay, we call it consumer surplus, right? Yes.
But then you forget the people who are gonna buy your product because it's expensive. They want to pay more. Then you assume that every person is the same.
No, I'm not assuming everybody is willing to pay the same. I'm assuming the first person is willing to pay this much, the second person is willing to pay a little bit less, the third person a little bit less, etc., and I'm ordering them. I'm putting first whoever is willing to pay most for my product. There's people who are willing to pay very little. That guy who only wanted to pay €2 is down here, okay? All I'm saying is there are people who are willing to pay more, there are people who are willing to pay less. If I'm selling, I could be selling to this guy, I could be selling at a very high price, and to the other guy at a lower price. I could be price discriminating, we will talk about that. But if I'm selling all the units at the same price, no matter whether you really like it or you don't, the first consumer is going to be the difference between how much he or she was willing to pay and how much they pay, right? The second consumer, how happy is she? Well, the difference between how much she was willing to pay and how much she pays. The third, etc., etc. So if we do all that thing, if this is the price and this is the number of units we sell, this triangle is the happiness the consumers are deriving from the fact that all units of my product are sold at the same price. Is it clear? So this is what we will call, and I will go through this next week, this is what we will call the consumer surplus. And because that consumer surplus, if the demand is a straight line, is a triangle, we can calculate in total how happy my consumers are by calculating the area of this triangle. Everybody's with me? What is the area of a triangle? It's length times height divided by 2. Why do we know that? Because if this is a rectangle, and the area of a rectangle is length times height, well, the triangle is half of it, right? So I calculate the area of a triangle with length times height divided by 2. Okay? That's it. So one question for sure, that one exercise that you will have to do in this course is, okay, calculate if this product is sold at this price, calculate how happy the consumers are, calculate the consumer surplus. So you will have to calculate that triangle. Okay? And there will be other shapes. We will look at to a trapezoid and some other basic shapes. But you know, just today I just want you to get the idea of this. Okay? Make sense? Good. We're doing very good in terms of that. Last thing, if there are no questions, are there any questions? Please, I told you, don't leave the room with doubts. Okay? I'm going to stay here till I die probably.
The last triangle, is it how people are unhappy?
Which one? This one? No, because actually, I mean, they are unhappy. They are unhappy. Why? They are unhappy because if you're selling these units at this price, these people who are willing to pay less than the price that you're charging, they are not buying the product, right? But they are, I mean, they are unhappy in general. You're unhappy because you cannot buy it, but you don't care. As a producer, you don't care because they are not your customers. You just care about the ones who buy from you. Who cares about the happiness of those people who don't buy you?
You're supposed to increase the rectangle?
Very interesting question. Of course, if you want to make that the consumers very, very happy, all you have to do is lower the price, and then the consumer surplus will be higher. But the problem, this is the interesting trade-off. The moment you lower prices, yes, it could be careful because the rectangle, it's true that the height will be lower, but the length will be bigger. So it could be that by lowering your prices, you can still get more revenue. There's a trade-off. There's a trade-off between lowering your prices and how many units you sell. And by the way, let's go, you know, Star Trek economics now. Let's go boldly beyond space. Depending on what is the slope of the demand function, this is something we will see next week. Whether the rectangle, the revenue, gets bigger or smaller will depend on whether the slope is very flat or very vertical. We will see that later. Good question. I see that I'm going to have a challenger in this course. It's going to be great. It's great. It's great to have somebody too. So please don't be, don't be shy. I know I don't have to tell you that, but don't be shy. Yeah. I'm very shy. So.
You want me to be annoying?
Nah, I'll be the annoying one. Don't worry. Especially on exam day. But anyways, is it clear? So we're going to be playing with these things, of course, right? We're going to have lower prices and then consumers will be happier. Of course, if the price is 0, everybody who wants to pay something for this product will buy it, but then we will get no revenue if the price is 0. So we will be praying about this. Because we will study most of these things from the point of view of the business person, right? We will not be very interested in making consumers happy. We will be most interested in getting as much revenue or as much profits, I haven't talked about profits yet, as we can. Okay? Yes? But you see that this course, even if it's simple in terms of the graphs and the math, we're talking about interesting things here. How do we make our profits the highest? How do we make revenue the highest? How do we measure, how do we value how happy our consumers are? Which type of decisions? And when I talk about decisions, I'm talking about, should I sell a lot of quantity or should I sell less quantity but higher prices? What kind of decisions I have to take in order to make my profits the highest possible? Right? Yes? Any other doubts? Last thing we're going to talk about, which is, sometimes in the same graph, we will not only represent one function, but we will represent two functions. So still, my graph is going to be, my axes are going to be P and Q, and there will be a demand function. I don't want to draw it yet, but there will be another function that is going to be interesting, which is going to be like that. Instead of downward sloping, it's going to be upward sloping. What could I be representing with a straight line that goes up? The higher the quantity, the higher the price. What could I be representing? If the other was the demand function, what could this be? It's the supply function, right? The supply function is going to be telling us what is the minimum price at which you have to sell your product in order to want it to sell the product, right? So instead of what is the maximum a consumer is willing to pay for a product, now you're thinking from the point of view of the producer, and you're thinking, okay, what is the minimum consumer should pay me in order for me to want to sell my product, right? And that is going to depend on what? If you are a producer or something, what is the minimum at which you would like to sell your product?
Production costs?
Your cost, right? If buying this jacket costs me 20, I will never sell it at a price below 20, right? So what am I selling? What am I saying? What I'm saying is that this supply function comes, and we will talk about this next week, comes from your cost structure, from your cost. Those, the same way as for consumers, there were some consumers who were willing to pay a lot for the product and others that were willing to pay less. Some producers will be willing to sell units of the product even if the price is very low, and some producers will only sell the product if the price is very high, right? What will depend on? What are the costs of these producers? There are producers for which producing something is very cheap, and other producers who will only sell the product if the price is high enough that covers their cost, because the cost of producing that product is very high for them, right? Imagine, now I'm going to show that I'm older than most of you, right? I'm a kid of I was born in the mid-70s, and I'm a 90s, When I listened to music, it was in the 90s. So imagine, this is something you will remember for the rest of your life, imagine I'm Britney Spears, okay? I know it's difficult. Imagine I'm Britney Spears, and I'm trying to sell concert tickets, right? I'm trying to sell my music show, right? My concert. If I'm Britney Spears, right? Of course I want to charge a very high price, but the minimum price they would have to pay me in order for me to do concerts, to sing, right? It will be very low because I'm Britney Spears. For me it's not costly to sing. It's what I was born a natural, right? That's, I'm sexy. I have a great voice. I look whatever Britney Spears does or did. Okay. Now, if I'm Pedro, I'm sorry if my examples are a little bit sexist. Okay. Now, imagine I'm Bruce Springsteen, right? Now we'll go to the 40s. Okay, to the 80s. If I'm a natural, my cost of producing something is going to be slow. So no matter if they pay me very little, now I would do it. Now, imagine I'm Pedro and I'm trying to sell concert tickets to the Pedro concert. So one thing is, who would be willing to pay to see a concert given by me? Probably nobody, right? The 2-year-old guy would say, no. Okay. But another thing is, for me, in order to give a high quality enough concert, such as people would be willing to pay for it, I would have to invest a lot. I would have to learn how to sing, I would have to dress differently, I would have to do many things. For me, it would be very costly. So the only way you're gonna see me, on top of a stadium singing songs, right, is if you pay millions and millions. If you tell me that, if you tell me, oh Pedro, if you go to Camp Nou at the end of the year and you sing in front of 100,000 people, we will pay you $3 million. I promise you, you will see it. For $3 million, we all have a price. For $3 million, I'm willing to do the investment, I'm willing to do the cost in order to produce that example. Okay? Now, why am I telling you all these things and this weird example? I should have come up with a better example. But why am I telling you this? Well, because the same way we have a demand function, we will have a supply function telling us what is the minimum price. At a very low price, very few producers will be willing to produce. If the price is higher, more producers will be willing to produce. Now, okay, so that's the idea of a supply function. We will talk more about that next week. But the important thing is, I told you, we're going to put in the same graph not one function, but two functions. We're going to have the supply function, and we are also going to have the demand function. Okay? And now, why I'm saying, and so what? Well, so what? There's going to be something very interesting here, which is there is a point where demand equals supply, right? There's a point in which if this is the price, all those consumers who are willing to pay more than that price, right, actually find the units, they can buy those units because the producers actually produce those units. So there is a price at which the market clears, at which there is a price at which all the units that consumers want to buy at some price, all producers want to supply it. If the price was higher, imagine the price was up here, P with a upper hat. Well, there would be a problem, because if the price is so high, only these consumers want to buy it. But of course, if the price is very high, many producers want to produce it. So there's going to be what we will call excess supply. If the price is too high, more producers will want to produce than consumers are willing to pay. So there will be excess supply. There will be more units in the market than actually are sold at that price. You can think that similarly, at a low price, right? If the price is very low, many consumers will want to buy, but because the price is low, many producers will produce it. So there will be excess demand. Okay? We will see all these things. So this point is going to be important because it's the point where the market clears, where it's at a point, at a price, at which all the units that consumers want to buy actually are produced. So everything that is produced is sold. The market clears, right? And now the last mathematical thing that I want you to learn is, okay, how do we calculate that point? And we remember from high school something that it was called a system of two equations with two unknowns. We should have to solve a system of two equations with two unknowns, right? What is the geometric or the mathematic property that that point satisfies? Well, that the price is the same for this function, for the demand function, and the supply function. The P is the same, you see? And the Q is also the same for the demand and for the supply. Meaning, if I have a demand function that, as we saw, it could be something like Q equals 20 minus 3P, for example, right? That's a demand function. How do I know that this is a demand function?
Negative.
That the slope is going to be negative. When I take the derivative of Q with respect to P, or the derivative of P with respect to Q, it doesn't matter, it's going to have a negative sign. So that no, because the derivative is negative, I know it's a downward sloping function. Now, that's the demand. Now, the supply will be something that it's Q that depends on P, but it's going to depend on a positive way. So, for example, 5 plus 2P, right? So, this is the demand function, this is the supply function. Now, how do I find this point? This is a point where the Q's are equal, yes?
When you equal those two.
Exactly. So a way to solve it is, I know if this is Q demanded and this is the price for the demand, and this is Q supply, and this is the price for the supply. These are not exponents, right? It's just a way to talk about demand and supply. I know that at the point that I'm interested in finding, QD equals QS, right? The quantity demanded equals the quantity supplied. So if QD equals QS, 20 minus 3P equals 5 plus 2P, right? If you want PD and PS. But of course, at the point that I'm interested in finding, the price that the consumers pay, the price of the demand, equals the price the suppliers receive. So the price of the supply. So PD equals PS. So 20 minus 3P equals 5 plus 2P. And all I have to do is put the p's together, right? So if I have 3P here with a minus sign, it goes to the other side with a positive sign. So going to be plus 5P. This is minus 2P. And if I have 20 with a positive sign, it goes to the other side with a negative sign. So 20 minus 5. So 15 equals 3P. Or not? 5P minus 2P? 15 equals minus 2P plus 5P? I'm doing something wrong? Yes, I'm doing something wrong. Why am I doing something wrong? Because I'm an idiot. This is another thing you will learn. No, Pedro, what are you doing with your math? It's been a very long day. So 20 minus 5 equals 2P plus 3P.
Okay.
Pedro, you are the man, the legend. Right? So 5P. So 15 equals 5P. Sorry about that. There will be many mistakes like that. So P equals 3. Everybody's with me? Thank you. I didn't do that on purpose, but it was kind of embarrassing. Anyways, I don't care about that. I care about you learning things, right? So if I make a fool of myself, if I make mistakes, it doesn't matter, as long as you learn something. So at that point, P equals 3. So I'm not only interested in how much P is there, I'm also interested in how much Q is there. So what can I do? I can substitute. Where do I substitute? In the demand or in the supply function? It doesn't matter, because at that point they are going to be equal. So I substitute in either of the two, right? So if P equals 3, for example here, 2 times 3 is going to be 6 plus 5, 11. So I have found that if this is the demand function and this is the supply function, when the price equals 3, the market clears. And actually 11 units of this product are sold. Right? Everybody's with me? Now, just as homework, just for you to think. Now I could say, okay, how happy are the consumers when the price is 3 and 11 units are sold? What do I have to do? Let's leave this open and I will solve it in the lecture next week. What would be the consumer surplus if the price is 3 and the quantity is 11? I have to calculate the area of a triangle. Very easy. What is the revenue? I have to calculate the area of a rectangle that has length 11 and height 3. This will be the revenue. This will be the consumer surplus. Everybody sees it?
Yes.
So that's it, basically. Any doubts, any questions? Anybody wants to type? Anything? You know, this is the level of math. Of course, the level, just a second, the level of economics that we are going to learn is going to be more interesting than that. But these are the math that you need to do. This. If anybody has doubts, questions, you know, just, can you give me, please, can you give me just 1 minute, please? Give me 2 minutes to finish. One thing that I would do, if I were you, I think most of you follow, which is nice. If I were you, I would start coming up with demand and supply functions, give them numbers, you know, and calculate derivatives, calculate maximum, minima, calculate consumer surplus, calculate revenue. Try to come up with numbers with this and solve it. If anybody does it and want me to check it, feel free to send it to me. You know, you can take a picture and send it to me through email or whatever, right? and I will be happy to help you. Just so for you know, my name is Pedro Rey, so my email is pedro.rey@esade.edu. My life is very sad, so that means I'm on campus, many hours. So, if you want to come to office hours, my office is 207E in the other building right there, right? On my webpage, I will also put things. So there's a webpage on Moodle for the course. I also have my own webpage if you want to check it, and where I put some material regarding the course. It's pedroreybiel.com. So it is pedroreybiel.com. If you are really, really eager, already on my webpage, I put a video. There's a YouTube video of a 20-minute summary of the whole course that I paid last year, right? Don't look at it, it's very embarrassing. But if you want to get an idea of what we are going to be doing during this course, you have that video. You probably will not see it now. You probably, whenever you have to study for the exam, you will probably see it many, many times. Or we will record a new one, okay? But if there are, I think it's obvious from the way I try to teach or whatever, I really enjoy doing this. So, if I can help, let me know, okay? See you next week. Have a good day. Eso será lo primero. Estamos haciendo, no sé si estudio economía, pero estamos haciendo básicamente una business version de un curso de microeconomía, que es estudiar monopolios, estudiar competencia perfecta, oligopolios.
Sorry. Like we had the first derivative, we found the the other point. If we take the second derivative,
I was being sloppy because I didn't want to complicate things. Thank you. No, but we are going to do this. I went very, very fast. I was already explaining equal concepts. I will record. If I were you, do the forward.
It says because in Brazil we don't have just even
That's true. So I'm trying to put everybody, we're taking people from all over. So if I were, you have a mobile phone? Yeah. Take a picture.
Bem perdida, eu sou a mais perdida no mundo, eu não acho as coisas.
Try to do these three derivatives.
Okay.
Try to do them at home and send me an email saying, okay, Pedro, I understand this, but not this. So try to send me an email.
I do the first and the second.
Even better, yes. Take
Okay.
first derivative and find maximum and minimum.
Okay.
Of them. And even try to represent the function. Try to do the graph in which your axes are x and y.
Okay.
So try to represent these functions, calculate maximum and minimum, and do the graph.
I will try.
Just try it. And when you see you have a difficulty, send me an email and say, okay, I'm able to do this, but this I cannot do it because, and I will reply.
Okay, thank you.
You're welcome.
Yeah.
Já pode chorar.
I'm getting ready to drop this back.
Pra caralho, pra ler ainda tem marketing na segunda e marketing tem muito material também pra ler.
thanks so much.
Was it useful or not?
Yeah. Good. It was a nice sort of recap. I mean, did a lot of that. I was worried we were going to do integration.
Because
and integrals is like, double integrals is a bit tough for me.
I don't know, it is, I mean, it's not super hard, but I decided to focus more on the concept, the core concept.
Oh, okay, cool. Are we going to need to do integrals in this MBA program or not really?
Not really.
Not really. Okay, cool.
Not that I know, but if you want to, we can. So
might as well go there.
okay, see you.
Thanks so much.
You're welcome.